Thanks, everybody, for coming. My name is Dave Copeland, or DaveTron5000 on Twitter, and I'm pretty excited to talk about this topic because it's something that I learned very late in my career, and it made me rethink a lot of assumptions. So maybe I'll convince you of the same thing. So I want to talk about Justin. Justin's the guy that I worked with at Stitch Fix. He's a very experienced engineer. That's not him, obviously. He didn't clear his likeness rights for this talk. So Justin, as I said, is a very experienced engineer. He is more experienced with networking, infrastructure, system administration, operations, things like that. But he's written a lot of code in his career, and he is a capable programmer. Now, if I were to ask Justin if he is a Rails programmer, he would definitely say no, not at all. But he's actually a pretty good Rails programmer. He's able to get things done in Rails, and it's no big deal for him. He views it as just a means of getting something done. So he and I were working on a project together, and this project involved building the deployment pipeline for Stitch Fix, and there's a lot that goes into that that isn't Ruby on Rails, but Ruby on Rails was a central part of this. So we were working on this application together, and there was a period where he and I were the only ones working on it. So we would review each other's code, as you do, because you should review code. So this is kind of how the code reviews went. So Justin would make a change, and I would review it, and pretty cool, right? Fine, you'd write code's fine, makes sense, good tests. Maybe I'd ask questions about AWS or something, but the code itself, the Rails part, no big deal, pretty straightforward. Now, when I would make a change, Justin's comments were usually of the form of like, why did you do it that way? Or what is all this stuff? Or what is going on here? And not because he couldn't understand it or couldn't go look up something, but he was just like, why did you not do it some other way? And his other way would always be with less stuff in it. And I would say, oh, well, dude, let me just tell you. The cyclomatic complexity of the code that I wrote is much lower, so it is less complicated. I did not use intermediate variables, which can cause confusion and make code hard to understand. And did you see that I use list comprehensions and functional style programming? Because it makes code way easier to understand when you do that. And as I'm explaining this stuff over and over, I'm like, why am I explaining code that is supposed to be easy to understand? Shouldn't I not have to do that if it is easy to understand? And it made me think about, like, what is it about the code that's not easy to understand? Is it Justin? I mean, yes, he's the one who's not understanding it, but like, should he be expected to understand it? Or should I maybe be expected to write code that he could understand? I mean, I wrote code that 50% of the team couldn't understand. That seems like a problem. And maybe the problem isn't Justin. Maybe the problem was me or the code that I was writing. And when I start to think about, like, how do we evaluate code, right? We run these code metrics on it, right? Some of them I'm kind of referencing up here. But the fact is, code doesn't exist in a vacuum. We don't like hang it on a wall and then just talk about how good or bad it is, because that's not how code is used. We don't use it that way. It always exists in some sort of context. And that context is actually pretty important when we think about, like, how good or bad the code is, right? What is the code for? How important is it that it works perfectly? We've all written one-off scripts. They don't need to be that well designed. They don't need to work that well. What if it's not going to change that often? What if it is going to change? That's pretty important to deciding how good or bad the code is and deciding about how we should write the code. But the thing I want to talk about are these last two, right? Whose job is it to maintain that code? Whose job is it to make sure that code is working and add features to that code? And who might be the type of people that we want to be able to change, modify, understand that code? And shouldn't that context be pretty important, right? If I write the most amazing code and nobody can understand it or maintain it, like, is it that amazing? I don't think it is. And, right, code metrics, right, they can't possibly have this context, right? How could they? You run your code through Code Climate, it doesn't know who's on your team, it doesn't know what your code is for, it just knows what your code looks like. It hangs your code on a wall and says stuff about it. And it's not wrong stuff, but it's not the whole picture. So let's look at some code and look at some standard code metrics and then see if we can sort of try to unwind this. So here's some code that sums up the cost of items in a shopping cart. Does everybody understand what this code does? Anybody completely confused by this code? It's okay. It's okay. So I would say this is pretty idiomatic Ruby code. We're not using Rails. We're not using active support. We're not using metaprogramming. We're using some stuff from the standard library. Most people who program Ruby know what a class and a method is and what an IVAR is. So pretty, I would say, not controversial, pretty idiomatic. I would write code like this all the time, and I would expect most of the people on my team to be able to figure this out. So let's look at some code metrics for this. So we have a baseline, right? We have a baseline of what the code metrics tell us about this idiomatic Ruby routine here. So I chose 4 of them that RubyConf can calculate. RubyConf is many things, but one thing it can do is perform these code metrics on your code. So method length, obviously, it's how many lines are in the method. ABC size is this sort of notion of like how many statements, branches, and conditionals are in the code, and that sort of gives us a sense of how complicated it is. Right? If there's more branches and more conditionals, maybe it's harder to understand. Cyclomatic complexity, that's a very, very old one that tries to count the number of pathways through the code. The thinking being if there's more paths through the code, it's more complicated or harder to understand. RubyConf has this thing called perceived complexity, which tries to calculate it in a different way. So we calculate all these, and it's going to give us this sort of baseline. Now, these values don't really mean anything. They don't have units that are meaningful, but they are meaningful when we compare these metrics to the same metrics for a different bit of code. So let's look at a different bit of code that does the same thing. Okay, does everybody understand what this code does? Yeah, a little grumpiness there. It's pretty gross, right? I would say that this is not idiomatic Ruby code, right? We got all these variables here. We've got a for loop. Anybody know how to do a for loop in Ruby? I had to look it up. I had never done it before. I had to look it up. And we got this nasty explicit return. Like, it just feels kind of gross. Like, this just doesn't seem good. It's more stuff. It just doesn't seem good. So what does RubyConf tell us? Well, RubyConf tells us in every way it's worse, right? It's a longer method. It's got a bigger ABC size. It's got a higher cyclomatic complexity. And it's got a higher perceived complexity. So all of this is telling us the second routine is more complex, therefore harder to understand, therefore worse, right? But whose job is it to maintain this code? What if you're a JavaScript developer and you get thrown at this code? Which version would you rather have to maintain? What if you're a Java developer? What if you just got out of boot camp and you haven't looked in the standard library for map and select? Which one would be easier for you to understand? So how do we quantify that? How can we try to figure that out? Like, how can we try to paint a picture of who could possibly work on this code or maybe someday could work on this code? So I decided, let me just count the things, right? What if we just count what you need to know? We can certainly itemize out everything you need to know to understand these 2 bits of code and see what that tells us. All right, so to understand this, what do you need to know? You got to know what a class is. You got to know what a def is, what a method does. You got to know what at line items does. You have to know what dot is. You have to know what select and map and reduce do, right? We're going through what you need to know to understand this code. You got to know what ampersand colon in stock question mark is and how come you can pass that to select. You got to know how come you can do that with plus. And you got to know, right, what this curly brace does. You got to know what this pipe does. It took me forever to figure out what the pipe was for. And you got to know what star does, and of course, how does the method get its return value? That's 13 concepts. So if you knew all these concepts, you should be able to understand that code. If you can understand that code, you should certainly be able to understand these 13 concepts. All right, cool. We'll write that down in our little metrics table. Now let's look at the more complex, grosser, nastier code that offends our sensibilities. What do you need to know to understand this code? Well, it's got class, def, at line items, dot, and star from the other ones. So you got to know those, of course, here too. What else do you need to know? You got to know what equals does. You got to know what this for loop does. You got to know what an if statement is. You got to know what plus does. You got to know what return does. That's it. 9, fewer things. Pretty interesting, right? It doesn't look good. We don't like it. RubyConf says it's bad, and yet it requires less knowledge to understand that code. You don't need to know as much stuff to understand that code, even though everything else is telling us it's more complex and therefore should be harder to understand. I think that's really interesting, right? I think it's really interesting. And if you wonder why people like the Go programming language, like this is kind of what it's getting at. So it makes me kind of question, what does it mean for code to be better? Like, I would say having to know less to understand code is a good thing. Good code shouldn't require knowing as much stuff, right? Or that's got to count for something, but yet these complexity metrics can't be ignored, right? If statements do create complexity. So how do we know what code is actually better? So I think we want to quantify it's like, what are we trying to do with code? Right? What do we do with code? What is the purpose of it? What are we trying to evaluate it against? Right? So we write code sometimes. We change code more than we write it. We read code a lot. Now, I don't know if this pie chart is exactly accurate, but it probably tracks with your experience, right? Why do we read code? Well, we need to understand what it does to explain its behavior, debug something. We need to read it so that we can then figure out what change we're going to make. And then we change it. We change code a lot. And then sometimes we write new code. But we don't write new code as much as we change code. And changing code and reading code are kind of forms of understanding that code, right? So we need to understand what the code actually does to, right, explain its behavior, to confidently change it, right? And so stands to reason, right, if we want to talk about what is better, well, all things being equal, code whose behavior is easier to understand should be better than code whose behavior is harder to understand. We talk about complex. What is the opposite of complex? Simple. What do those mean? They mean understanding, right? So if code is easier to understand, that's better than code that isn't as easy to understand, right? But by that definition, I understand all the code that I've written, and you do not understand that code, so therefore my code is better than yours, right? Like, not true, right? That's definitely not true, right? Who is the person that's supposed to understand this code? That is what I'm getting at. This is what matters. You might say, hey, what are you doing with a Ruby job if you don't know how to do map and reduce and all that stuff? I mean, I don't know. Like, I'm not going to make a list of what Rubyists like have to know. Or you could say, I learned that stuff. It's easy. No problem. Everybody can figure out what map does. I mean, maybe some stuff is easy to learn, but some stuff is hard. I told you about the pipes, right? I didn't learn Ruby for like 6 months because I couldn't figure out what those pipes were for. Like, that would confuse the hell out of me. So I don't want to tell anybody what's easy or hard to learn, but it is worth thinking about, like, you know, learning stuff and whose job is it to learn stuff and how are we going to get them to learn what they need to learn. So remember Justin from the beginning. So this is Josh, not really. So Josh joined the team with Justin and I. Josh is also an experienced engineer, not as experienced as Justin, but still very experienced. His experience is very similar to Justin's in that it's the world of networking and operations and system administration, AWS and things like that. Although Josh has not had the good or bad fortune to do as much programming in his career as Justin had. So Josh is a little less experienced as a programmer, but he's on a team, and part of that team is to maintain this Rails app, and that means writing Rails code. So we want Josh to be able to do that, and Josh wants to be able to do that. So what's interesting is when Josh looks at the code that I wrote that is less complex and better and functional style and list comprehensions and all of that, he's like, what is this? Not like, how dare you write such horrible code, but literally like, I don't understand what I'm looking at. There's a lot going on. How do I pick this apart? When he looks at Justin's code, which is less fancy and gross and has more stuff or more lines of code, he's like, I get it, and he's able to be effective. I find that really interesting, right? So we have someone who is on a team whose job it is to maintain an application, and there's parts of that application that he can confidently change and parts that he can't. And I would say because of who he is in the team and what the team is trying to do, the parts he can't change, maybe that's not good code. Maybe if he could change it all, that would be better. So let's look at the concepts again. Because as I said, Josh has done a little bit of programming. He can do some bash, things like that. All right, so all of this stuff here on the right that I've highlighted, those are the things in the first code listing that are not required to know in the second. And look at them. They're pretty complicated. Like, what do you even call ampersand, colon, in stock question mark? What is that even called? How would you even know to ask what that is? These are like very Ruby-specific things. If you know JavaScript really, really well, you're not going to have any intuition about many of these things. Compared to this, right? How many programming languages have plus and if and for and return? How many programmers know what these are? Probably a lot. So this is the TIOB index, and we can debate this or not, but I think this tracks enough to make my point, which is that most programmers know a programming language that has if, for, and return in it. And so most of these programmers who look at the second code listing will have a pretty good intuition of what it does. When they look at the first code listing, that's less complex, they have a lot more to learn. It's going to be harder for them to understand what's going on there, harder for them to understand the behavior of that code. It's pretty interesting, right? Now, 10 years from now, maybe this is going to be all closure, right? And my point will not stand any longer. It's possible. But for now, it does stand, and I think that's important to consider, right? If you think about who can we bring onto our team, maybe if we said, you've got to be a seasoned expert Rubyist, maybe we wouldn't have hired Josh because he's not a seasoned expert Rubyist. But we had a little bit of an environment that he could be successful, and so we were able to hire him. I think there's some power in thinking about that. So, right, what did we just show, right? The more complex code, not only does it require fewer concepts to understand, but the concepts it does require are more universal. I'm just going to keep hammering home this point because I think it's really fascinating. So think about the value of code and who can understand it. Code that only the author understands, not a lot of value there. Code that like everybody who's responsible for maintaining it, they should be able to understand that. I think if you have a team that can't understand all the code they have to maintain, that's a problem. Probably want to start addressing that problem. But what about code that everybody at your entire organization can understand? That would seem to be very valuable code. That would seem to be good code, right? If anyone on your entire company's engineering team can understand a certain bit of code, that seems really, really good. What if everyone that understands Ruby could understand that code? What if you wrote code that anyone who is a Rubyist, by any definition, could understand? That seems amazing, right? Wouldn't that be the most amazing code? If you're building an application in a team and you could make it out of code that every Rubyist could understand, that's pretty good, right? What about every programmer in the whole universe, right? If you could write code that every programmer everywhere could understand, that would be amazing. I want to see that, right? That seems valuable, right? And so the hyperbole here is saying that like the more people that can understand the code, there's more value there, right? You're getting more out of that code because more people can understand it, explain its behavior confidently, change it, right? So, right? And you can think about this stuff, right? How learnable are the things in the code, right? Could any programmer learn this? Any programmer knows what those things are probably. What about a programmer that only knows an OO language? Well, cool, they know what a class is, they know what a method is, so they're going to learn those things more quickly than a functional programmer who maybe doesn't know what those things are. Ruby programmer. Obviously, a Ruby programmer is going to know, like, if they know some Ruby code at one company, they're going to know it at some other company. There's a lot of intuition there. What about someone with only a year of experience? What about someone with 20 years of experience? Right? So you can start to pick apart of all the concepts that are in your code, all the things someone needs to know to understand that code. What does the person look like that could possibly understand all that code? Right? It paints a picture of who can actually be on your team. And when you're making changes to the code, I think it's really interesting to think about not just how many if statements did I add and how many features of Rails am I using, but who am I now making their lives difficult if they want to be on this team? Or whose life am I making easy if they want to be on this team? So you could try this very easily as a thought experiment, and I'll show you an example. Right? Look at the next change you're going to make. You can count how many new concepts are we adding. And then you can tell yourself, you can objectively know, does everyone on the team understand these concepts? And if not, you can then kind of get some intuition. How hard would it be for the rest of the team who doesn't understand these concepts to learn them? And did we just decrease the number of people who could understand this code? And you can start to get a cost to adding these concepts beyond their effect on complexity. So let's add a tax calculation to our thing. And I'm sorry for the simplicity of this. Anyone who's done sales tax knows it is not at all like this. But nevertheless, it's a good example. So we have a default tax rate of a typo, which is 45%. And then DC has 10%, California has 5%, and Virginia has 3%. And then we're going to just add that into our total price as we kind of sum everything up. Does everybody understand how all this works, right? Constant, we all probably know what a constant is. Hash.new, everybody know what hash.new does? It doesn't just make a new hash. It makes a new magical hash that returns a value that you give it when there's no key. Tap, everybody know what tap does? I'll tell you, and it will not illuminate you at all. Tap, you call it on an object, and it yields that object to a block, and it returns that object. Right? Makes sense. Square brackets, of course, right, dereference the hash. Okay, so that's what you need to know to understand this. What if instead we just made a method called like calculate tax and just had like a bunch of if statements in it? I mean, that's nasty, right? Like, just oof. But yet, what did we do? We only introduced equals equals. Who knows equals equals? Like everybody who has any level of programming experience probably knows what equals equals means. I find this really interesting because that just looks so gross to me, and yet I can't deny the fact that it might actually be better. Right? And so we can rerun the metrics on our change code, and we can see that our second diff that used all those if statements, it made the complexity measures worse, but we introduced fewer concepts. Interesting. Okay, so we should never use new concepts then, right? I mean, I don't know, right? We've been told there's power. We have these powerful programming languages, all these sharp knives. Aren't we supposed to be using sharp knives? Isn't it okay? Are we not supposed to feel guilty? Like, we have sharp knives. Aren't we supposed to use that stuff? Like, what is it there for? I mean, maybe, right? Are they sharp or are they shiny? I mean, I think when you look at features that I'm going to show you through the lens of what does it take to understand that, I think it starts to give you a sense of like how many features are actually that powerful and how worth it is that power. Our spec, right? So the way that this is sold to us as programmers is that it reads like English and it explains what it is. It is expected to be isosceles and be equilateral. Cool, right? You can see the programmer intent. But what actually happens here? And how would you figure that out? Like if you Google be isosceles, you're not going to find anything. You have to know how this works, and to know how this actually behaves is pretty complicated. Like, it requires knowing a lot. I had a hard time ensuring that this was still possible in RSpec because I don't know what this B isosceles, I don't know what that's actually called. So compared to this, I mean, this is testing the same thing. This is doing the same thing, but it requires knowing lots of less stuff. So is all of this powerful tools? Is this a sharp tool that we shouldn't feel ashamed of using? Or is this like creating a bunch of work for somebody to have to learn before they can actually do something? I don't know, right? It's a cost and it's a trade-off. Okay, what about this? Now, you're probably saying, oh my God, you've repeated resources comments twice. How could you possibly ever make such horribly duplicated code? Well, if you're not familiar with Rails 4, the problem has been solved with routing concerns. So this creates this. Okay, so right, this is, I mean, kind of weird concepts. It's actually more code. I don't know, like, if this is actually solving something, right? This is, again, power, a sharp knife, but is it really needed? What if we really hated this duplication so much? What would we do if we didn't know about routing concerns? Well, we'd make a method. Most people know how to make a method, right? That's pretty gross. If you saw a method being declared in your routes file, you would probably say something. Yet, it's hard to deny that more people could figure this out than who could figure this out. So I don't want to, again, this is a way to look at abstractions, to look at features, to look at libraries, look at all this power, and try to figure out exactly how worth it really is, right? Because who is on your team actually matters a great deal. If you use every feature of Rails and you are left with something that no one on your team can use, that's a problem, right? Maybe, I mean, that's a problem for everyone. You have to do all the work. They don't do any work. Work is slow. That is not good, right? So the way to kind of start thinking about this is when you're adding a new concept to your code or bringing in some new feature of the language or the framework or adding some new library, you're getting a benefit out of that. Hopefully you're getting a benefit out of that. But that benefit has a cost. And that cost is either the cost to bring everybody along to learn whatever the thing is, or the cost of leaving people behind and maybe preventing people from being effective at that code. And I don't want to put any judgment on either of these. Like, I can think of scenarios in which both of these costs might make sense. But it is a cost, right? It's not zero. Neither of these is zero. And so what I'm saying is you can use this lens of number of concepts and how hard are they to learn and how hard would they be to learn for my team as a way to start to think about how you can quantify these trade-offs and talk about, should we write code this way? Should we add this library? Most of us remember that Twitter used to be written in Rails, and then they switched to Scala. And if you know both of those languages, you know that Scala is very, very alien compared to Ruby and Rails. It's very, very different. It has lots and lots of concepts. I think it might have all the concepts. Rails obviously doesn't have all of them yet. So it's a big transition. Now, if Netflix had done this, they would have fired everyone and then hired a bunch of Scala developers. But Twitter did not do that. They created this thing called Scala School, which is essentially this way that if you're a Rails developer at Twitter and your job is you need to learn Scala, well, now you can. They've created, this is what you need to know to be effective. They paid the price to bring everybody along. So they decided that the power of Scala was worth it, and they were willing to pay to bring everybody along to do that. Interesting. Okay, so we've been talking a lot about code and code metrics. But if you've done anything that is beyond just writing code, there's a bunch of stuff that is actually really complicated other than the code, right? So here is my just imagined architecture diagram, right? We have an app, there's caches, load balancers, CDNs, servers, there's a bunch of stuff, and it's pretty complicated. And it can be very, very complicated. It can be very hard to learn and figure out. And when we run our code through RubyConf and Code Climate, we're really only getting information about the class's methods, right, the code that we're writing. But this concept, what I've been harping on this whole time, you can apply that to anything. It is fractal because it doesn't necessarily require understanding the code's elements, right? So imagine that you need to diagnose a slow query, and you have determined that this method is where the slow query is coming from. So what do you need to know to diagnose this problem? Well, you got to know what all this is, all these scopes and whatever. You got to know what SQL it's going to generate, what that SQL means. You got to know how that SQL gets applied to the database. If you wrote your code differently, in a more gross way that many will not like, by just putting SQL directly in your Rails code, well, how have we changed it, right? Well, now you still have to know the SQL and the database stuff. Like, you're not getting around that. But now, to understand the code part, you just need to understand some standard library calls and how to dereference a two-dimensional array. And guess how many people understand that versus understand this, right? More. Think about the DevOps team, or whatever you call them at your company. They could certainly figure this out enough to go diagnose this problem. And having problems that more people can diagnose seems better than problems that fewer people can diagnose, right? All because we put gross SQL in our code. Right, monolith versus microservices this is a really good lens to understand this dichotomy, right? If our monolith is small and does few things, then lots and lots of people can work on it because it's pretty easy. Everything is there. All the reasons that you've heard why you should write a monolith, those all apply in this case. Microservices requires more complexity. There's more stuff going on. You got to know more. It's harder to understand the whole system. There's a lot there. But when your monolith gets ginormous and huge and has lots and lots of stuff in it, the skills required to work in it change. You can't just write simple code anymore. You have to understand how that's going to interact with potentially complicated thousands and thousands of lines of code. You have to know about modularity and how to separate concerns and all these things to keep the monolith something that you can be effective in. That's a different skill than working in a tiny one. And when you think about that and you compare that to microservices, maybe it's a little bit different. Maybe the trade-off is not so obvious there. The last example is setting up a Postgres database, right? Anybody can do that, but this is the most expensive way to run Postgres, absolutely. But anybody can do this. Now you might think, oh, just run RDS, it's so much simpler. I mean, no, it's not. It's cheaper, but you still gotta know a bunch of stuff. That scroll bar probably should be bigger. There's a lot of stuff you gotta know to run RDS on AWS. Oh, but you could just run it on an EC2 box, right? Here's all the instructions to set it up on EC2, right? No problem. So there's a trade-off here. In the Heroku case, you're paying a lot of money to let anybody manage your database. And in the EC2 case, you're paying less money to have one person be able to understand that. I can't tell you which one of those is right, but that's the way to think about this trade-off. Okay, so you've got metrics now. I don't think they're bad. They're not terrible. They're fine. But this is another one to think about, right? Think about, what do you have to know to work on the system? And as you change the system, how are you changing what you need to know, and who is being left behind? And are you committed to bringing them along? And maybe you can't. Maybe you're in a situation where you can't afford to bring people. You can't make Scala School happen. Well, what you can do is you can write your code and design your systems in a different way that doesn't leave people behind, if that's the trade-off that you want to make. So that is what I have. If you want to hear someday read more about things that are not sort of with the common wisdom, I have this new thing I'm working on, so click on that and sign up. I also totally spent 40 minutes doing this talk when I was practicing. I have not done it in 30, so we have some time for questions if anybody has them. Are there any tools that count the number of concepts? Not that I'm aware of, but I bet you could get hired by CodeClimate if you came up with one. Yeah, this is a good one. The question is, we came to Ruby because it's this expressive, wonderful language with all these cool features that feel good, and it feels good to do it. And how do you balance that with, me telling you that there's a legit use for a for loop? It's interesting, right? I mean, I think it's another piece of the puzzle, right? If there are people on your team who that is a motivator for them, then to tell them to stop using that stuff and only use for loops, they're going to be very upset about that. And I think that matters. So again, it kind of gets back to the people on the team and what is the plan for the people on that team. I don't know. It's a little wishy-washy answer, I guess. But question is, what do I mean by interesting? When my mother tells me that my haircut is interesting, I know exactly what that means, right? It doesn't mean good. It means she's being very polite. So I don't mean that. I mean that it gives me this new way of thinking about something that I thought I understood. I thought I understood, hey, this is good code. This is how we know good code. That is solved. We've closed that case. And when I had this experience that I relayed with Justin, it made me reevaluate what do I actually think. And it's hard to deny some of what is in here as being valuable. And so that's why I thought it was interesting. It just gave me personally this whole new take on something that I thought I had kind of figured out. Maybe it's not as interesting to everyone as it is to me. I'm advocating that we all code in VB. I guess what I'm saying is if we did code, if we did do that, there is some value there. Now to his point and to the point about abstractions and power, there's some loss. You're paying for that, but you're actually getting something. It's not all bad. It actually could be good. And I think the way to know how good it is to think about who am I trying to get on my team. If I'm going to hire 20 people out of boot camp, I probably need to write the simplest, easiest to understand code so that those people can be effective as soon as possible. Or maybe I want to write the craziest metaprogramming code ever, but I'm going to get them up to speed. So I think it's just part of the calculus. Okay, so the question is, as a newcomer, do you challenge people on that? I mean, you got to figure out what the vibe is to see figure out what the norms are, what is okay. I do think, so the reason why I had been blind to this concept was because in the past, hey, why are you using all that stuff? The question would come from someone with less experience. So the answer is, oh, well, you don't have enough experience. Let me educate you. And when the questions came from someone with a lot of experience, I was like, wait a minute, maybe I'm wrong here. Oops. So I don't know the good answer to that, but I think it should always be okay to ask what's going on here, what is all this stuff? And then maybe if you build some trust, maybe you can start to ask, hey, what if we did it simpler? What if we did it a different way? But that kind of totally depends on who you're dealing with. Questions about how do you measure how fast it is for someone to come on to your code base? I haven't, like a technique that I used before was to just try to give the person very simple tasks and gradually increase the complexity. Not super scientific. Yeah, I don't know. I think that's interesting because that is part of this, right? If you hire someone, it takes them 6 months before they're effective. That's a problem, or that's just something you should know when you're hiring someone. I don't know. I think that kind of gets to it, but I haven't. So the question is this introducing more bugs into our code or a potential for that? So that's also an interesting take because it's a common trope and probably common knowledge that the average number of bugs per line of code is the same, right? And so therefore, right, the Perl programmers of the world are going to say write fewer lines of code, then you'll have fewer bugs. I don't know. It is kind of true. So it is hard for me to look at this huge nasty if statement and say, well, there's a lot of opportunities for bugs. Maybe we shouldn't do that. So I don't know. I mean, I think that is possible. And again, it's a trade-off. Like we want to do this super functional, super lazy Haskell madness. Then you gotta train people to do it if you want to do it, or you gotta accept that you're not going to hire a bunch of people because they don't know it. I don't know. Again, I'm punting to the same trope over and over again, but I think it makes sense. So what's the difference between the cost to understand the code and the cost of running the code? Yeah, I mean, if the code is not performing to the specifications that it needs to, then it has to, right? The code its purpose is to run and solve some problem. So obviously, I definitely subscribe to the school of make it readable, whatever your definition of readable is, and then if it performs poorly, observe that as a fact and fix the specific problem. Don't write it to perform well at the get-go because there's no reason to do that. That's just adding complexity. But yeah, I mean, I think it's totally legit to say this code is super gnarly because it actually has to run fast for all of these reasons. And I'm sorry I can't make it more clear, but this is the way it is because, yes, the code has to execute. That if it's not running, it's kind of pointless. What does my T-shirt say? Jesus Christ, that was loud. It is the 4 keys on the keyboard that was used to develop VI. So it says HJKL and has the arrow keys because VI is the best. Thank you.